Welcome back, guys. In this video, we're going to start working with quadratic functions. So we already discussed some quadratic functions when we were working with polynomials. So quadratic functions are basically polynomials of second degree. So we are going to be dealing with variables to the second power. And most of the time, you're going to see them in the following format. A times x squared plus b times x plus c. And a, b, and c are very important and very useful when it comes to working with quadratic functions. Now, let me elaborate why. So let's start with c. C is going to be our y-intercept. You can see that when you plug in 0 for x, you're going to end up with just c. And a and b are going to be very useful when locating vertex and zeros of a function. And probably for now, you have no idea what vertex is and what zeros of a function mean, and that's what we are going to cover next. So to describe vertex and zeros of a function, I'm going to insert a graph. Well, actually, let's do it in black. Let's insert a coordinate system and draw a quadratic function that goes like this. So all of the quadratic functions are parabolas. Then they can be facing up, like in this case, or they can be facing down. So few things about our parameter a. That's right before x squared. So if a is greater than 0, then we're going to have a smiley face. Our parabola is going to open up. If a is less than 0, then we're going to have a sad face. And parabola is going to face down. Now let's discuss a vertex. So vertex is this point, kind of the point where your parabola starts shooting up. It's also your y-intercept. And now I'm going to tell you how to find the vertex. So the formula for the vertex is negative b over 2a. So that's the x value of the vertex. And y value of the vertex is our function evaluated at negative b over 2a. And don't worry if that doesn't make sense for now. We're going to do plenty of examples when you will be given a chance to evaluate vertex, find a vertex using different methods. This one, however, I believe is the easiest and the fastest one to find a vertex. So take a mental note, put it down on paper, put it down on your iPad or your phone, and have it readily accessible whenever needed. Now, let's talk about zeros, right? I mentioned zeros, that a and b are going to be very useful when it comes to finding zeros. So zeros of a quadratic functions are the points where your y value is equal 0. So once again, our coordinate system, this is the y-axis, this is the x-axis. So in majority of quadratic functions, depending on how they are located in the coordinate system, you're going to have two zeros if they interact with the x-axis. And zeros Let me actually write it down for you. So zeros are values of x that make f of x equal 0. And that's also the y value. And there's two ways to find zeros. Number one is factoring. And that's why we covered factoring before we covered quadratic equations or quadratic functions. And second one, well, there's actually three, right? If you have a graph, you can just spot them on a graph. So graphically. And third one is using the quadratic formula. So by now you're very familiar with factoring, so that might be the easiest choice for you. But if any of you are like me and you absolutely suck and despise factoring, then you're going to be stuck with quadratic formula. Why? Because some of the functions are not easily factorable. And with quadratic formula, you can easily find values of x that make f of x equal 0. Therefore, you can easily find zeros of functions or solutions that will make your quadratic function equal to 0. So the way you find x1, 2, so that indicates all the zeros, or all the x-intercepts, is negative b plus minus square root of b squared minus 4 times a times c, and all of that divided by 2a. And if you're going to use this formula, with a function that's not factorable, regardless of what b, what a, and what c is, you'll be able to find the zeros if such exist. But we learned factoring for a reason, right? Factoring is going to be probably one of the fastest and perhaps easiest ways that you can find zeros without doing all of these crazy calculations. So if you haven't done so, please watch the video about factoring and make sure that you master all the ways to factor. One of them is a perfect square. Another one is the AC method. Another one is simply factoring out a variable or a number and simplifying your expression. If you're capable of factoring, that is going to make working with quadratic equations a lot easier. Obviously, you're going to have cases of quadratic functions that do not have any x-intercepts. And let me do two examples. So you don't have to take my word for it. You can actually see how these graphs look. So first one is going to be x squared plus 2. So this is f of x equal to x squared plus 2. So it is just a regular quadratic function that is opening upward because our a is plus 1, but our y-intercept is equal to positive 2. So the entire graph is shifted upwards. You can see that at any point or at any x value, the graph doesn't interact with the x-axis. We can still plug in different values for x, and we're going to get a corresponding and unique y value for each one of those. But the graph is not going to interact with x-axis. Another case would be x squared or negative x squared minus 2. So this is f of x equal to negative x squared minus 2. So a is less than 0, therefore our parabola is going to open downward. We're going to have a sad face. I think that description helps a lot of students. And we're going to shift our graph by 2 units. So this is y equal to negative 2. And once again, we do not have any interaction with x-axis. Therefore, no zeros. Yet again, whenever we plug in different x value, we're going to obtain a unique y value. So hopefully this intro to quadratic formulas makes sense. What I want you to take away from it is the following. Be comfortable with what A, B, and C mean. A determines if your parabola opens up or down. In the next video, when we start graphing quadratic equations, I'm going to tell you a little bit more about A, if it's greater than 1 or if it's less than 1, what's going to happen with the graph of our function. B is very useful when you're trying to find the vertex, or if you're calculating zeros using the quadratic formula. And C is always your y-intercept. Now, zeros of a function are values for x that make f of x equal to 0, hence the name zeros. And keep in mind, you have 3 ways to find zeros. Don't worry, we're going to practice all of them. Number 1 is factoring the function. So if you have a perfect square, you can factor it out and you will find 2 solutions for x that make it equal 0. Sometimes it might be 1. Sometimes your function won't have any zeros, like we just discovered using these 2 graphs on the bottom. Another way is to do it graphically. In the next video, we're going to cover graphing functions, and doing it that way, you'll be able to determine both the vertex and the zeros of a function. And lastly, if all hope is lost when you try factoring, when function is too complicated to graph it, you can always resort to using the quadratic formula, but be prepared to conduct some calculations. Most of the time, the numbers are going to be fairly easy to deal with, but once in a while, you'll end up with a fraction underneath the radical or something bizarre and really large that is not so easy to calculate. All right, see you in the next one.